Hello guys, my name is Manish. Today I will teach you about Java data types. I assume that you have a little bit of programming experience in C and C++. So let's get started. So starting with the basic definition of data type. What is a data type? Data type is a type of the value that a variable can store in it. Here, just see this declaration byte B, which means that B is going to hold a value of the type byte. This is I is going to hold a value of type short and goes on like that. There are two types of data types in Java. Those are primitive data types and non-primitive data types. In this video, I will tell you about primitive data types. There are 8 primitive data types in Java. Those are byte, short, int, long, float, double, char and boolean. These all 8 can be put in 4 different categories: byte, short, int and long. These 4 will can be put in integer category, these in floating number category, this in character category, char is in character category and boolean in boolean category. Now we'll discuss about first with integer category. Now byte is the smallest integer data type. Now this is the declaration. This byte is the type of the variable and b is the identifier. This is how a byte variable is declared, and this is uh, anything. This is the declaration combined with initialization. Byte is signed 8-bit type, which means that you can think of it as storage or memory allocation, and the range of this byte is from -128 to 127, which means that b can hold only values from -128 to +127. You cannot have any b cannot store any values greater than 127. It shows you an error. And next, a byte is used when you are dealing with raw binary data. And now moving on to with short is the least used integer type. This is signed 16-bit type. You can as I told you that this is the storage it consumes, and this is the range -32768 to 32767. This is the range of the short data type. I can hold only values between this. Next, moving on to integer is the most commonly used Java type. Integer is also used in array indexing and for loops, control statements and everything. This is signed 32-bit type, and if you want the ranges of all these data types, I have provided a link in the description. You can go and check it out, and this will have a little high range when compared to short. And this is also this is the declaration combined with initialization. And now this long, coming on to long, this is declaration of a long variable and initialization with it. Here you have to append an l to it, which explicitly specifies that this is a long literal, and this is signed 64-bit type. The value of this long is very huge, and when you use this data type when that integer is unable to hold the desired value. Just assume that you are calculating the velocity of light, or any distance between sun and moon. That is going to be very huge. So at that time you need to use a long variable where integer cannot support that. And now moving on to the floating point category. What is a floating number or floating point? Which can be any number with some fractional precision. 4 is a number, the fractional precision is 0.46. This is the fractional precision. See, this is the declaration of the floating variable float f, and this is I have combined this with initialization to make it clear. I've wrote this code before to save you some time. And this is signed 32-bit type, and I'll tell you why I have written this f here. And now moving on to double d is 4.67, which if here you can think that 4.67 is right. If you don't specify a capital D here, like capital D usage of capital D has become redundant, because even if you don't specify this, the literal 4.67 is considered as, by default it is considered as a double literal, so you need not specify the capital D. Even if you specify, there's no problem with that, but when you remove this 4.46 is considered as the default double value. So when you're trying to assign a double value to a float value, it gives you an error, because that type of automatic conversion is not possible, so you have to append capital F to it. And the usage of this in, like, uh, if you want fractional precision but not with higher degree of accuracy, then you must use float. If you need high degree of precision and everything, very high degree, very accuracy, then you must use a double. Here you can have maximum of 6 digits after the decimal point if you are using float, and if you are using double, you can have a maximum of 15 digits after the decimal point. We are done with floating point category, and now moving on to the char category. As you are familiar in C or C++, this is signed 16-bit type, and the range of this is from 0 to 65536. There are no negative chars here, so the range will be from 0 to 65536. All the ASCII techniques that you have used in C and C++ will work perfectly for in Java. Like the ASCII set is from 0 to 256, I think, if I'm not wrong. And next, we can mess with this all these characters that you have messed with uh, uh, in C or C++. Anything you can perform, addition and incrementing, anything you can perform. And here the char in Java is entirely different. They are having a very slight difference, is from the char data type in C or C++. There is a difference between them. In C++, char is 8 bits wide, here it is 16 bits wide, because here char uses Unicode, which means that you can represent any language, any human language, with Java character set. That is the only difference. And next, in this, coming on to boolean uh, can hold only two values. Either it can be true, or you can have a true or a false. These are only the possible logic values. These play a very important role when you are using in if statements, or um, any relational operators, where the return type of the relational operators is boolean. And so this is it with the data types. And if you I'll give you some code. Just try this. Just declare the byte b is equal to minus, I'm sorry, just declare byte b is equal to 127. 127 is the maximum rightmost value. You cannot have 128. You know that b plus plus increments the value of b by 1. Now when you increment 127 by 1, it is 128. It is out of the byte range. Do you think that this code is valid? This b plus plus system dot out dot println, which prints the value of b. If you think that this code is valid, come on, comment down below the output, comment on below. And if you like my video, please do subscribe to my channel, and don't forget to leave a thumbs up. So thank you for watching.